Hello, in this video I will be explaining to you how Subnautica and Subnautica Below Zero can relate to science. In this video, we are in Subnautica. So, as you can see, my reference point is my life pod, which is this thingy, and you can see right here. And I am currently 22 meters away from it. So my reference point is my life pod, so the place I choose to use as a reference, or the starting point I choose, and I'm going to turn around and be in motion because I am changing position. So now if I turn around, now you can see that I have moved away from the life pod because the starting position I chose was the life pod, but now I'm 180 meters away because I went into motion and moved away from the life pod, and now my position has changed. Now I will show you net force. So net force is pretty much the sum of forces acting on an object. So let me show you what's happening here. Sorry, this is very slow for some reason. So we got my prawn suit here, which is grappled to this thing, which is called a Reaper, and it's a Leviathan. And pretty much this, so the grappling arm, like this line, is pretty much what is being pulled on, kind of like in tug of war. So this is pulling up in kind of that direction with some force, and my thing is like pulling it down with some force. So if we go over to here, you can see the net force. The Reaper is pulling with a much greater force than my prawn suit, but my prawn suit is pulling with some force. So let's say this is, the Reaper is pulling with 100 newtons, and my prawn suit's pulling with 25 newtons. Well, that means that the net force would be, our sum of forces, or net force, is 75 newtons in this direction, because the Reaper is pulling with 100 newtons of force, the prawn suit is pulling with 25 newtons of force, and if you subtract 100 from 25, it is 75. So the sum of forces is 75 newtons. So this is the important thing. The sum of forces is 75 newtons. Next, I will show you Newton's first law, which states that an object in motion will stay in motion, and an object at rest will stay in rest. So my example of this is, as you can see here, there's this swimming fish. It's called a bladderfish. It is swimming, and it will keep swimming and staying in motion unless another force acts on it to stop it. And in this case, the force stopping it is gonna be my hand. Don't worry about the text pop up at the bottom. That's just that happens in this game. So as you can see, it is now no longer in motion. But if I let it go, it's back in motion. So again, this bladderfish is in motion, and it will stay in motion unless another force stops it. And that force was me stopping it. You can go now, fish. So, yeah. That was Newton's first law. Now I'm going to show you speed. So as you can see here, we have this submarine, which is called the Cyclops. And as you can see, there's a beacon right there that says speed test. I'm going to time it and see how long it takes on all three of these different speed modes to get there. And then we're going to figure out how fast it went. Alright, let me start a timer, and here we go. Alright, going. Alright. So far we're 10 seconds in. And passed it. Okay, so it took us 17 seconds to get to that. Now, I'm going to quickly go back, get into position, and I'll be right back. Okay, now I'm back into position. Just getting the timer ready. Okay, the timer is ready, and we have it on the next speed mode. So, let's go. Already it's going significantly faster. We're only 5 seconds in. Right, 10 seconds in, and it's so much faster than the other one. And we've passed it. Okay, that took 15 seconds. Yes, so it took 15 seconds on the normal speed. So, one last time, I'm going to get back into position, and I am going to do it one more time. Alrighty, now I'm going to put it onto the fastest speed mode. So we're on the fastest speed mode. Get the timer pulled up, and 3, 2, 1, go. Alright, we're going. It's going significantly fast. Oh wow, it's a lot faster. And we have passed it. So that took about 13 seconds, which is by far faster than any of the other speeds. So now let's see which one went the fastest. Well, which one makes the most sense. So looking at how long it took for each one, the slowest one took 17 seconds, the medium speed one took 15 seconds, and the fastest one took 13 seconds. So for each one, it went down by 2, but overall, this is the biggest thing, to go 100 meters, to go as slow as it could, the Cyclops took 17 seconds. To go about in the middle of how fast they can go, the Cyclops took 15 seconds to go 100 meters, and as fast as it could go, the Cyclops only took 13 seconds to go 100 meters. So it's pretty obvious which one is the fastest. Also, it says that anyways. Alrighty, so we are still in the Cyclops, and I'm going to demonstrate velocity. So the velocity is the speed and direction of a moving object. So let's get this started. So as you can see, we're going to be going north. So there's our direction. Our speed is gonna be slow. That's the wrong button. Alright. Here we go. So as you can see, our velocity, well, we're going north and we're going slow. So that's our velocity. North and slow. Slowly, we're going slowly. As you can see, we're not going very fast. So that's velocity. Alrighty, now I'm going to show you force and friction, but let's start with force. Force is a push or pull on an object. So a push on an object would be, let's say, so as you can see, I'm applying force to this docking module. That's what it's called, a docking module. I'm applying force to it. So this is an example of force. Now I will show you friction with this prawn suit. Alrighty, so friction is a force that resists the sliding motion two surfaces that are touching. So as you can see, I'm walking around, I'm not sliding. That's because of friction. I'm not sliding because there's friction, which is resisting this wanting to slide, which is allowing me to walk. If I jump, and friction. So it's it's the force that is causing me not to slide. So I'm not just like zooming across here, like whee, well, now I'm using a jetpack, but yeah. So that's force and friction. Next, I'm going to be showing you Newton's third law and gravity. So Newton's third law states that, like, when you apply force to an object, there will be an equal and opposite force from the object that you applied force to. So pretty much if you run into something, the amount of force that you apply to that, it'll apply to you, which is one way to demonstrate here. If I run into this rock, I get pushed back, and the harder I run into it, the harder I get pushed back. If I just barely run into it, I just barely get pushed back. So I run into it hard, I get pushed back hard. So, and then I will also be showing you gravity. For that to work properly, I need to get onto a little piece of land real quick. Alright, so on Earth, the gravity is pretty strong. When you jump, you get pulled back down pretty quickly towards Earth's core, because that is what is causing gravity. And yeah, so the gravitational pull on Earth is pretty strong. So here, also this planet is not Earth. If I jump, I get pulled down pretty quickly. I would say about a second, which seems fairly similar to Earth, maybe a little weaker, but this is quite similar to Earth's gravity. Now I will show you Newton's second law and acceleration. So acceleration is a measure of change of velocity in a certain period of time, and velocity is the speed and direction of a moving object. So we are currently facing north, and our current speed is 0. But so let's see what happens in 5 seconds. 1, 2, 3, 4, 5. Oh, trying to stop. Oh, geez, trying to stop. Okay, we stopped. So you can tell we accelerated because 1, our speed changed, our direction did not change, but our speed changed, and we still know what our direction was. So we were, so our velocity changed during a period of 5 seconds, so that was acceleration. Newton's second law states that the acceleration of an object equals the net force on an object divided by the object's mass. So you can see this in Subnautica below 0 because, you know, I need to sneeze. Sorry, I'm back from my sneeze. So let's say this thing weighs 100 kilograms and these thrusters push with 300 newtons. So if this thing weighs 100 kilograms and these thrusters push with 300 newtons, that will mean our acceleration will be 3 meters a second squared. Because the formula for this is acceleration in meters per second squared equals force in newtons divided by mass in kilograms. So our newtons is 300, our mass is 100, so therefore our acceleration would be 3 meters per second. Lastly, I'm going to show you force pairs, which is the force objects apply to each other. So as you can see here, we have 2 CMOS. And hypothetical, so you can see this. So what's going to happen is you're going to run into each other. Now, since this is a single player game, I cannot physically drive both of them at the same time. But I can show you this diagram. So if, let's say this is CMOS 1 and this is CMOS 2. If they're going and they run into each other, they're going to start going in the opposite direction because they're applying force to each other, and the force they're applying to each other is being distributed back into them because they're running into each other. So, like, another example that does not have to do with this is if you hit a tennis ball with a tennis racket, the tennis ball is going to go forward, but it's also going to apply some force to the tennis racket when they collide. It's the same situation here. When the sea moss collide, when these collide, they are going to go in different directions because the force from this one is pushing this one this way, and the force from this one is pushing this one this way. That is what force pairs is. The force, and since force pairs is the force two objects apply to each other, when this one applies force to this one, it'll go this way, and when this one applies force to this one, it'll go this way, or that way. So that is force pairs.